Hey guys, in this video, we're going to talk about the law of cosines. So this is still section 5.4, part B, where we talk about law of cosines. If you missed the lesson on the law of sines, then you need to get out of this video and go see part A for section 5.4 and view that lesson on the law of sines. But in this one, we're going to talk about law of cosines. So we're going to start off first of all by talking about when it's appropriate to use the law of cosines. And when we use the law of cosines, it's for scenarios such as side angle side or side side side. That's what we will use the law of cosines for. So when we have a triangle that meets those requirements or that criteria, then we're going to use this law, and you can see these equations, how they're set up. This is kind of talking about each angle compared to each side. And this is for my triangle that is labeled ABC. If you notice over in here, the way that this is structured is that the uppercase A is across from the lowercase a, the uppercase B is across from the lowercase b, the uppercase C is across from the lowercase c. So everything is kind of paired up that way. And we will take the values from our triangle that we do know, and we'll plug them into one of these equations so that we can see and solve for everything that's missing. So again, when we talk about solving a triangle, it just means find all of the missing parts. So I think it's a good idea for us to get in the habit, at least here at the beginning, it's a good idea for us to get in the habit of taking inventory, take stock of what you do know versus what you don't, so that you make sure you find everything that you need for your triangle. So first thing I'm thinking of is, okay, if I was going to solve this triangle, I would know angle A, I would know angle B, and I would know angle C. Now, at this point in the problem, I only know one of those things. I know angle C. But I also would know side A, side B, and side C if this was fully solved. I do know two of those things. I have A is 11, I have B is 5. But everything else is missing. And so we're going to have to go on a journey to find those missing parts. All right, now the law of cosines. Let's kind of talk about how this is structured so that we can actually work a problem. So yes, the triangle, we already talked about the fact that the uppercase A is across from the lowercase a, uppercase B is across from the lowercase b, uppercase C across from lowercase c. So that's kind of that structure. When you set up your law of cosines, I want you to see like the patterns here. Do you see how the side A squared starts this first equation, and then it ends with cosine of A squared? If you look at the next one, it starts with B squared, it ends with cosine of B. Starts with C squared, ends with cosine of angle C. So when you set up these things, that's going to be the pattern. If I am looking for, say I wanted to find side A, I could use this equation to find side A, but I would need to plug everything else into it, and it would have cosine of A at the end. If I wanted to find angle B, I would have used angle B, the cosine of angle B equation, right? Because that's the only place where that's even a thing. And so we kind of have to just adjust our brain for whichever we're trying to solve for. Also want to point out that in some cases, your triangles may not always be labeled as A, B, and C. Your triangles can be labeled as anything. It could be labeled as X, Y, and Z. It could be labeled as P, R, and Q. You can label these things whatever you want to label them. You're not limited to just A, B, and C. So you just have to adjust and follow the pattern that we have for this. All right, let's talk about this question. What we're missing, what we can work towards. So on this triangle, we've already kind of taken inventory here. We have seen that we are missing two angles and we are missing one side. Now, if I was only missing one angle, that would be an easy thing to find. However, since I'm missing two angles, that makes things a little more challenging. I do see that I have two of the sides and I'm missing a third. I think it's going to be in our best interest if we find that third side first. So That's kind of the way I go about these is if I don't already know all the sides, if it's a law of cosines one, if it happened to be side, 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 it'd be good. But because this one is side, angle, side, I'm needing to figure out that third side before I get the angles. So I'm going to start there. I'm going to figure out what is C. Now, since I'm looking to find C, all right, let's make a couple notes. Number one, this is side, angle, side. Therefore, we're using law of cosines, which I kind of already said. But now if I want to find C, we're going to say to find C. We're going to give ourselves just some extra little information here so that you guys can follow this a little bit more when you're looking back at your notes later. To find side C, I'm going to use the equation that starts off as C squared equals. That's what I'm going to start with. So we're going to say here, C squared equals A squared plus B squared minus 2AB cosine of angle C. Excuse me. All right, so let's solve this. I don't know C, that's cool. But I do know everything else. We're going to plug in the A, 11 squared plus B, 5 squared, minus 2 times A times B, cosine of angle C. Angle C we do know as 20 degrees. So I'm just plugging everything in that we do know, and we're going to solve for what we don't. And in this case, since I do have everything on this right side of the equation, I can just go to my calculator, make sure your calculator is set in degrees, but I can just type this all in. The calculator will do the order of operations for us, so you don't have to break it down into a bunch of steps if you have this set up. All right, I'm going to double check, make sure I've got it all typed in right. Okay. All right, so once we type that in, it's going to give us a decimal. Now, there's something we got to watch out for. Okay, a very, very easy mistake is the decimals. And I think I alluded to this a little bit in our last video, but it's incredibly important that you only really truly round at the end. Now, it's kind of difficult to leave this in exact form throughout the whole problem, but I would, at the very, very least, leave all of these decimals in here until the very end, and at the end, round it. You're going to see on the assignment that I give you guys, it's going to tell you to round to the nearest 10th place, but I would not round it here in the middle of the problem. I would wait until the end to round, okay? That will keep us from having issues. All right, so I'm going to square root both sides. On the calculator, you can just hit the square root and then the answer button. It'll type it all straight in, and it will tell us 6.52945723. But for the final answer, we'll go ahead and round this to be 6.5 for C. Okay. So I do have side C now. I'm going to go back to my little answer boxes and let's include that. So for my final answer, yes, we're putting 6.5. Now here's something I got to point out though. Anytime I have to use C again in my calculations, anytime I need to go back and use C, I'm going to need to plug in the bigger decimals, not the 6.5. Okay. We did not leave these in exact form. It would be even better if we had left them in exact form and plugged those in. But at the very, very least, use all the decimals that the calculator gives you in your calculation, and that will keep your numbers more precise. Okay. All right, so I did get side C. Now I can go about getting my two angles. Now you can get either angle in whichever order you want to. I could solve for A or I could solve for B here. That is completely a personal choice. I'm going to go for A just because I want to, but it doesn't really matter. So I'm going to go down here, try to give yourself a decent amount of space because we are going to plug those things with the decimals in, and that is kind of a space waster. So we're going to make a little note here. Say to get angle A. All right, what are we going to use to get angle A? We're going to use the equation that has angle A in it. There's only one. The only one that has that in it says cosine of A at the end. So that's the one I'm going to use, okay? I'll try to keep that visible on the screen for just a moment. But I'm going to use that equation where it says A squared equals B squared plus C squared minus 2BC cosine of angle A. All right, so that's the one I'm going to use. I'm going to plug in the numbers that I know and then solve for the ones that I don't. This time I do know this number here on the left, so I'm going to say A squared, that's 11 squared, equals B squared plus. And now here's something I want to watch out for. Remember what I said a minute ago. Rather than using 6.5 when I plug the C in, I need to use the thing that's going to be a little bit more precise. And I want you to look. If I'm plugging in a C squared, we actually have a number for C squared early in our problem. That's this 42.6338, that big long decimal. I can actually plug that in here in place of C squared. So I'm going to put that here. This is the 42.63381171. Then we're going to have minus 2 times B times C. Now, again, I'm not using 6.5. I'm going to use the long decimal for C. I'm going to use 6.529455723. I'm going to use that whole thing. It's better than using the one that we rounded for our answer. It's going to give us a more precise answer. It's even better if you can leave the exact form in there, but that always seems to be one of those things that I have trouble keeping kids to do. So at least put all of the decimals in that you see on the screen. All right, at the end here, we're supposed to have cosine of A. So remember how I said you got these long decimals to put in, you need space. All right, from here we're going to solve. Now here's a little bit of a challenge compared to the last part. In the last part, I was able to put the whole right side in the calculator because I knew all the things over here. However, since I don't know what A is, I can't do cosine of A. And therefore, I cannot put the whole right side of the equation in the calculator. We're going to have to take this a little bit more step by step and work this through completely, okay? So 11 squared, 121. 5 squared, 25, plus 42.63381171 minus, and we can multiply these. You can use a calculator if you want to, but it's not that bad. 2 times 5 is 10. 10 times anything just scooches the decimal place over. So this would make 65.2945723 cosine of A. The number one mistake I see from people at this point is if you have successfully gotten the equation set up and everything plugged in, I do see some people who are having issues with PEMDAS and not completely working this bit correct. I do see people that will combine all three of these numbers. They'll combine the 25, 42, and the 65. But the problem is these three numbers can't all be combined because this last one is attached to cosine of A. So I cannot combine that one. I can add these two together. Okay, I can do that, but I cannot combine it with this minus 65. So we've got to be real careful, okay? When we add these together, we do get 67.63381171. We still have minus 65.2945723 cosine of A. Whew. All right, again, we cannot add these together. We cannot put these together. So the next thing I'm going to have to do is subtract this 67.63381171 on both sides. 81171. So that bit will go away. When I subtract this, we should get, let's see, minus 67.633. Right, I got 53.3661889 And over here on the right, we still have this minus 65.2945723 cosine of A. Next thing, we are going to divide by negative 65, right? We're going to divide by this, negative 65.2945723. And we're going to divide by that over here as well, negative 65.2945723. So that part will go away. It's honestly better if you leave this in fraction form and then do the trig thing. So I'm going to do that. I'm going to say, I'm just going to rewrite it. Most of the time, you're able to just kind of do this stuff straight into the calculator. But I'm trying to show you guys a little bit more detailed here. That's equal to cosine of A. So what we need to do at this point is I have cosine of A equals a number. I'm going to do the inverse cosine. And when I do inverse cosine, that's when I get cosine to go away on that other side. They cancel each other out. Cosine inverse and cosine gone. And we're going to cosine inverse my fraction here. All right, so cosine inverse, you're going to hit shift, then cosine. Then we're going to type in this fraction right in here. Okay, so I type that all in. And I got 144.8168425. That is what angle A is equal to. $8168425. Okay. So I have angle A now. We're going to round that to the nearest 10th place from my answer box. So when I record my answer up in here, we're going to put 144.8 degrees. Okay, we have that part. Next, the last bit, I have to get angle B. And while some of you guys might be like, oh no, now I have to do the same thing I just did for angle B, others of you guys have realized that you don't. Because now at this point, I have got two angles. And we know that triangles, the angles add up to 180 total. So what I'm going to do is I'm going to go over here to the side. I'm going to say to get the measure of angle B, we're going to do 180 and then subtract the two angles that we know. We're going to subtract 20 and that 144.8. And you may use the rounded one right here at this point. Using this is not going to make a difference on your answer. So I would go ahead and just let that be. So you'll do 180 minus 20, and then minus 144.8. So we can get our final answer here to be 15.2 for the measure of angle B. Ta-da! All right, so law of cosines is definitely more work than the law of sines. You have to be more careful about your decimals. If you're not, you're going to run into problems, especially with just if you're dealing with that rounding error. It's very easy to mess up and get the wrong decimal place at the end. So just watch out for it. You don't want that to be the reason why you miss a problem, is that the decimals are rounded wrong. That can be very disappointing. But that's law of cosines, guys. I'm only going to do the one example for this video, so we just have that one. But they all work that way, all the law of cosines. If you have side, it just means that you are not going to end up having to solve for the side first. You would do two of these type of situations to get two of the angles, and then you can subtract them from 180 and get the missing one. So that's really the only difference. You still use law of cosines if it's side, side, side. All right, guys, that is it for this video. Good luck on the assignment. As always, reach out if you ever have any questions, and I will see y'all in the next one. Bye.